ਇੱਕ ਓਕਾਰ ਸਤਨਾਮ ਕਰਤਾ ਪੁਰਖ ਨਿਰਭਉ ਨਿਰਵੈਰ ਅਕਾਲ ਮੂਰਤ ਅਜੂਨੀ ਸੈਭੰ ਗੁਰ ਪ੍ਰਸਾਦ God is everywhere and in everyone. He is truth, immortal, creator, without fear, without enmity, unborn, and self-creator. This understanding comes by the Guru's grace. काहे रे मन चितवै उदम चा आ रहे हर जीव करया. O my mind, why do you worry for your living, when the Lord Himself is taking care of you? सैल पत्थर मा जंतु पाए ताता रिजक आगे कर करया. He created the living beings even in the rocks and stones, and supplied their provisions beforehand. Today we are going to discuss unit number 7, P block elements. The deleted items of this unit are preparation and properties of phosphine, sulfuric acid, industrial process of manufacture, oxides of nitrogen, उनका structure ही है, phosphorus electroforms, compounds of phosphorus are also deleted, preparation and properties of halides and oxoacids of phosphorus, it is also deleted. After studying this unit, people will be able to appreciate general trends in the chemistry of elements of group 15, 16 and 17 and 18, learn the preparation property and uses of dinitrogen, phosphorus and some of their important compounds. Compounds of phosphorus are deleted. Describe the preparation property and uses of dioxygen, ozone, and chemistry of some their oxides. Describe the preparation property and uses of chlorine and hydrochloric acid. Know the chemistry of interhalogens and structures of oxoacids of halogens. Enumerate the uses of noble gases. Appreciate the importance of these elements and their compound in our daily life. Group 15 include nitrogen, phosphorus, arsenic, antimony, and bismuth. Nitrogen and phosphorus are non-metals. Arsenic and antimony metalloids, and bismuth is a typical metal. First point regarding these, molecular nitrogen comprises 78% by volume of the atmosphere. In the earth crust, it occurs as sodium nitrate, NaNO3 called saltpeter, and potassium nitrate called Indian saltpeter. It is found in the form of proteins in plants and animals. Now, what's about the existence of phosphorus? Phosphorus occurs in minerals of apatite family, that is Ca9PO46, CaX2, X is equal to FCl or OH. Examples are fluoroapatite, that is Ca9PO46 and CaF2, which are the main component of phosphate rocks. Phosphorus is an essential constituent of animal and plant matter. It is present in bones as well as in living cells. Phosphoproteins are present in milk and eggs. Arsenic, antimony, and bismuth are found mainly as sulfide minerals. Let's have some basic knowledge about group 15 elements. First is electronic configuration. The valence electronic configuration of these elements is ns2np3. ns2np3. S orbital is completely filled and p orbitals are half filled, making their electronic configuration extra stable. Atomic and ionic radii. Covalent and ionic radii increases in size down the group due to increase in number of shell, as we know about the previous knowledge of 11th class. There is a considerable increase in covalent radius from nitrogen to phosphorus. However, from arsenic to bismuth, only small increase in covalent radius is observed. This is due to the presence of completely filled d or f orbitals in heavier element. These d and f orbitals have poor screening effect. Due to this, the size is not increased up to the mark. Third one is ionization enthalpy. Ionization enthalpy decreases down the group due to gradual increase in atomic size because of the extra stable half-filled p orbitals, electronic configuration, and smaller size. The ionization enthalpy of group 15 elements is much higher than that of group 14 elements in the corresponding periods. The order of successive ionization enthalpies as expected is delta H1 is lesser than delta H2 is lesser than delta H3. These are the ionization enthalpies for the removal of first, second and third electron respectively. Electronegativity. The electronegativity value in general decreases down the group with increasing atomic size. However, among the heavier elements, the difference is not that much. Physical properties. All the elements of this group are fully atomic. Dinitrogen is a diatomic gas while all others are solids. Metallic character increases down the group due to decrease in ionization enthalpy and increase in atomic size. The boiling point in general increases from top to bottom in group, but the melting point increases up to arsenic and decreases up to bismuth. Except nitrogen, all other members show allotropy. Yeah, chemical properties, oxidation state, and trends in chemical reactivity. The common oxidation states of these elements are -3, +3, and +5. The tendency to exhibit -3 oxidation state decreases down the group due to increase in size and metallic character. In fact, last member of the group, bismuth, hardly form any compound in -3 oxidation state. Point B, the stability of +5 oxidation state decreases down the group. The only well-characterized B5 compound is BIF5. The stability of +5 oxidation state decreases and that of +3 state increases due to inert pair effect down the group. Inert pair effect is already studied in class 11th. Nitrogen exhibit +1, +2, +4 oxidation states also when it reacts with oxygen. Phosphorus also shows +1, +4 oxidation state in some oxoacids. In the case of nitrogen, all oxidation states from 1 to 4 tends to disproportionate in acid solution. 3HNO3 changing 3HNO2 changing into HNO3 plus water plus 2NO. Similarly, in case of phosphorus, nearly all intermediate oxidation states disproportionate into +1 and -3 both in alkali and acid. However, +3 oxidation state in case of arsenic, antimony and bismuth become increasingly stable with respect to disproportionation. Nitrogen is restricted to maximum covalency of 4 since only 4 1s and 3p orbitals are available for bonding. The heavier element have vacant d orbital in the outermost shell, which can be used for bonding and hence explain their covalence as in PF6. Now, anomalous properties of nitrogen. Nitrogen shows anomalous behavior, that is a different behavior from the other members of the family. Why it does so? It is due to following reasons. First one, nitrogen differs from the rest of members in this group due to number one is smaller size, high electronegativity, high ionization enthalpy, non-availability of d orbital in valence shell, unique ability to form p-pi multiple bond with itself and with other element, having small size and high electronegativity, for example carbon and nitrogen. Dear student, whenever reasoning question is asked based on nitrogen or nitrogen is involved in any kind of reasoning question, why n is doing so and other are not doing, why n is not doing so and other are doing, nitrogen is doing something but other element are not doing, नाइट्रोजन कुछ कर रहा है बाकी एलिमेंट कोई प्रॉपर्टी शो नहीं कर रहे वो प्रॉपर्टी नाइट्रोजन शो कर रहा है या नाइट्रोजन कोई प्रॉपर्टी शो नहीं कर रहा दूसरे शो कर रहे हैं देन वी विल हैव टू राइट ऑल दीज 5 reasons एंड वी विल गेट full marks. Now, heavier elements of this group do not form p-pi bond as their atomic orbitals are so large and diffuse that they can't have effective overlapping. Thus, nitrogen exists as a diatomic molecule with a triple bond, 1s and 2p, between two atoms. Consequently, its bond enthalpy is very high. On contrary, phosphorus, arsenic, antimony form single bonds PP, ASAS, and SbSb, while bismuth form metallic bond in elemental state because bismuth is a metal. Now the question may be asked from here. Nitrogen exists as N2 while phosphorus as P4. Why? The again answer is above 5 options. The nitrogen have small size, high electronegativity, high ionization enthalpy, non-availability of d orbital, its unique ability to form p-pi bond. If we write all these reasons, that will be okay. Examiner will give you the full marks. Are different than the other element, it is due to mainly these 5 reasons. और कोई एलिमेंट कोई काम करता है नाइट्रोजन नहीं करता है, नाइट्रोजन करता है दूसरा नहीं करता है, तो किसी भी क्वेश्चन में अगर नाइट्रोजन की इन्वॉल्वमेंट आ रही है रीजनिंग में तो ये 5 पॉइंट बिना सोचे समझे लिख दीजिए, आपको नंबर पूरे मिलेंगे. इट्स क्यों करता है नाइट्रोजन का एनोमलस बिहेवियर, क्यों है? स्मॉल साइज, हाई इलेक्ट्रोनेगेटिविटी, हाई आयनाइजेशन एंथैल्पी, नॉन अवेलेबिलिटी ऑफ डी ऑर्बिटल इन वैलेंस शेल. नाइट्रोजन का वैलेंस शेल सेकंड है, सेकंड में 2s होता है, 2p होता है, 2d नहीं होता, तो इस कारण से इसकी गुण जो अलग है बाकी एलिमेंट से. यूनिक एबिलिटी टू फॉर्म p-pi मल्टीपल बॉन्ड विद इटसेल्फ एंड विद अदर एलिमेंट, स्मॉल साइज एंड हाई इलेक्ट्रोनेगेटिविटी. दूसरे एलिमेंट है जिनका साइज कम है इलेक्ट्रोनेगेटिविटी, जैसा जैसे कार्बन और ऑक्सीजन के साथ भी मल्टीपल बॉन्ड बना लेता है. तो बेटा हैवियर एलिमेंट है जो दूसरे वाला है हमारे पास. ये क्लियर हुए बेटा यहाँ तक पॉइंट? यस यस सर. हाँ आयुष, चंद्र किरण, जशन, हेलो. हाँ बेटा ये चैप्टर 8 नंबर का है, बड़ा लंबा छोटा चैप्टर है, इसमें से रीजनिंग क्वेश्चन आते हैं. Third point is, however, the single bond N is a weaker than a single single pp bond because of high interelectronic repulsion of the non-bonding electron due to the small bond length in case of nitrogen. As a result, catenation tendency is weaker in nitrogen. Fourth point is, in case of nitrogen, there is absence of d orbitals in its valence shell. Due to this, its covalency is restricted to 4. It can't form d-pi-p-pi bond as the heavier element can. For example, R3p double bond O, R3p double bond CH2 R is alkyl group exists, but R3N double bond O, R3N double bond CH2 do not exist. This question may be asked and the answer will be Nitrogen is not able to form d pi p pi bond due to its small size again. Not phosphorus and arsenic can form d pi bond also with transition metals when their compound like PC2H5 thrice and AsC6H5 thrice act as ligands. What are ligands? We studied in coordination compound. First property, chemical property, reactivity toward hydrogen. All the members of group 15 form hydrides of the type EH3 where E is equal to N, P, AS, SB, Bi. Then hydride will be NH3, PH3, ASH3, SBH3, BiH3. Now, some properties of these hydrides and their explanation is given next. The stability of hydride decreases from NH3 to BH3, that is on moving down the group, due to decrease in bond dissociation energy on moving down the group, due to increase in atomic size. It is first property. पहली प्रॉपर्टी है कि इनकी जो स्टेबिलिटी है डाउन द ग्रुप डिक्रीज करती है. डिक्रीज क्यों करती है? क्योंकि जो सेंट्रल मेटल एटम है जैसे नाइट्रोजन फास्फोरस डाउन द ग्रुप साइज बढ़ता है. साइज बढ़ने के कारण जो सेंट्रल मेटल है और हाइड्रोजन है उसके बीच का जो बॉन्ड लेंथ है वो बढ़ जाती है. बॉन्ड लेंथ के बढ़ने से बॉन्ड डिसोसिएशन एनर्जी डाउन द ग्रुप डिक्रीज हो जाती है. तो इसके कारण स्टेबिलिटी भी डिक्रीज हो जाती है. पॉइंट नंबर सेकंड, द रिड्यूसिंग करेक्टर ऑफ द हाइड्राइड्स increases from NH3 to BiS3 again due to decrease in bond dissociation energy on moving down the group. For example, ammonia is only a mild reducing agent while BS3 is the strongest reducing agent among all the hydrides. हाँ जी, जो रिड्यूसिंग नेचर है इनकी, रिड्यूसिंग नेचर क्या होती है? टेंडेंसी टू गिव एच. तो टेंडेंसी एच देने की डाउन द ग्रुप बढ़ती है क्योंकि डाउन द ग्रुप साइज बढ़ता है. साइज बढ़ने से बॉन्ड लेंथ बढ़ जाती है. तो बॉन्ड लेंथ बढ़ेगी तो बॉन्ड टूटना आसान हो जाएगा. बॉन्ड डिसोसिएशन एनर्जी डाउन द ग्रुप घट जाएगी. हाइड्रोजन आसानी से मिलेगा. तो रिड्यूसिंग करेक्टर भी डाउन द ग्रुप इंक्रीज कर जाता है. तो नेक्स्ट इज बेसिक नेचर, बेसिसिटी also decreases in the order. NH3 strong basicity, then PH3, ASS3, SBS3, BIS3. This is due to the decrease in electron density on central atom on moving down the group. Or in other words, we can say due to this nitrogen have maximum affinity for proton due to its high electron density. Next point is bond angle decrease from NH3 to BiS3 due to decrease in bond pair and lone pair bond pair repulsion on moving down the group due to increase in size and decrease in electronegativity. Boiling point decreases on moving down the group due to increase in size because when van der Waals forces are डायरेक्टली प्रोपोर्शनल टू साइज. डाउन द ग्रुप जाते हैं बॉइलिंग पॉइंट बढ़ता है. क्यों बढ़ता है? क्योंकि डाउन द ग्रुप साइज बढ़ेगा. साइज बढ़ेगा तो एटॉमिक मास भी बढ़ेगा. तो एटॉमिक मास के बढ़ने से वैन डर वाल फोर्सेस बढ़ जाती हैं क्योंकि वैन डर वाल फोर्सेस आर डायरेक्टली प्रोपोर्शनल टू साइज. इस करके बॉइलिंग पॉइंट इंक्रीज हो जाता है. NH3 हैज एक्सेप्शनली हाई बॉइलिंग पॉइंट due to presence of intermolecular hydrogen bonding due to its small size of nitrogen atom. NH3 का जो boiling point है that is exceptionally high. ऐसे भी कह सकते हैं NH3 लिक्विड है, बाकी सारे हाइड्राइड क्या हैं? गैस हैं. इसका रीजन क्या? पेपर में क्वेश्चन आया है कई बार. तो NH3 में एक यूनिक प्रॉपर्टी शो करता है. NH3 कैन फॉर्म इंटरमोलिकुलर हाइड्रोजन बॉन्ड्स ड्यू टू वेरी स्मॉल साइज ऑफ नाइट्रोजन एटम. Yes, reactivity towards oxygen. All these elements form two types of oxides, E2O3, E2O5. The oxides in the higher oxidation state of the element is more acidic than that of lower oxidation state. Their acidic character decreases down the group. The oxides of the type E2O3 of nitrogen and phosphorus are purely acidic, that of arsenic and antimony amphoteric, and those of bismuth is purely basic. Reactivity towards halogen. These elements react to form two series of halides, EX3, EX5. We already know PCl3 and PCl5. Nitrogen does not form pentahalide due to non-availability of d orbital in its valence shell. In other way, we can say NCl3 exists but NCl5 does not exist. Why? This question asked in the examination several times. NCl3 एग्जिस्ट कर जाता है, NF3 एग्जिस्ट कर जाता है, but 5 may not exist because there is no d orbital in valence shell in case of nitrogen. Pentahalides are more covalent than trihalides. All the halides of these elements except those of nitrogen are stable. In case of nitrogen, only NF3 is known to be stable. Trihalides except BiF3 are predominantly covalent in nature because bismuth is a metal and metal generally form ionic compounds. Reactivity towards metal. All these elements react with metals to form their binary compounds exhibiting -3 oxidation state such as Ca3N2, Ca3P2, Na3As2, Zn3Sb2 and Mg3Bi2. Now we are going to now solve some questions based on group 15 elements. Question number 1. Though nitrogen exhibit +5 oxidation state, it doesn't form pentahalide. Give reason. Answer is nitrogen with N is equal to 2. Outermost shell is second, has S and P orbitals only. It does not have d orbital to expand its covalence beyond 4. That is why it does not form pentahalides. Now question number second, pH3 has lower boiling point than NH3. Why? Answer is again same, that is unlike NH3, pH3 molecule are not associated through hydrogen bonding in liquid state. That is why the boiling point of pH3 is lower than NH3. हमें पता है NH3 में इंटरमोलिकुलर हाइड्रोजन बॉन्डिंग होती है, pH3 में नहीं होती. NH3 का बॉइलिंग पॉइंट इसलिए ज़्यादा होगा pH3 से. हाँ जी, नेक्स्ट क्वेश्चन नंबर थर्ड क्वेश्चन, why are pentahalides are more covalent than trihalides? In pentahalides, oxidation state of phosphorus is +5, while in case of trihalides it is +3. But we know that covalent character is directly proportional to oxidation state of central atom on previous knowledge of +1 class. Therefore, pentahalides are more covalent than trihalides. Question number 4. Why is BiS3 strongest reducing agent amongst all the hydrides of group 15 elements? Because it has least bond dissociation energy due to its large size. Question number 4. What is laughing gas? Answer is N2O is known as laughing gas. Nitrous oxide is laughing gas. Question number 5. What is the covalence of nitrogen in N2O5? That is 4. Nitrogen does not form pentahalide. Give reason. Again, due to absence of d orbital. Question number 5. Why does NO2 dimerize? NO2 contain odd number of valence electrons. Question number 8. Ammonia is a good complexing agent. Give reason. Ammonia has a lone pair of electrons, therefore, on nitrogen atom, therefore it is a good complexing agent. Question number 9. N2 is considered as a inert gas at room temperature. Why? It is due to the presence of triple bond. It has very high bond dissociation energy. Question 10. PCl3 gives fumes in moisture. Why? It is due to following reaction. PCl3, 3 water changing into 3 HCl that is that appear as fumes and H3PO4. Question number 11. NS3 is more basic than PS3. N is more electronegative than P, so electron cloud is more on N. Hence, proton affinity is more in case of NH3. Now, are all the 5 bonds in PCl5 molecule equivalent? No, there are 3 equatorial bonds and 2 axial bonds. Axial bonds are longer than equatorial bonds. This structure of PCl5 is studied in +1 class in chapter chemical bonding. Question number 13. PCl5 behaves as an ionic species in solid state. PCl5 behaves as an ionic species in solid state. Yes, answer. Solid PCl5 exists as PCl4 positive, PCl6 negative. PCl4 species exist as tetrahedral and PCl6 negative species as octahedral. Now, question number 14. P form PCl5 but nitrogen cannot form NCl5. Why? Again, answer is due to absence of d orbital in N. Now, question number 15. Bond angle in pH4 positive is higher than pH3. Why? pH4 has tetrahedral arrangement, pH3 has pyramidal arrangement. So, due to lone pair bond pair repulsion, bond angle is less in pH3. Explain the following. N exists as N2, whereas phosphorus exists as P4. And second is NF3 is exothermic compound and NCl5 is an endothermic, NCl is an endothermic compound. Answer is NN single bond is very weak due to its small size. इस कारण से N exists as N2 molecule and P exists as P4 molecule. NF3 क्यों exist करता है? NCl3 endothermic क्यों है? NF3 exothermic क्यों है? F is highly electronegative and NF bond energy is higher than the NCl bond energy. Question number 17. NH3 is more basic than PS3. Explain. Write the condition which favor the production of ammonia by Haber process. Answer of question 1. NH3 is more basic than PS3. And answer is due to small size of nitrogen, there is more electron density at nitrogen atom. Condition for the production of ammonia by Haber process. Favorable conditions are high concentration of reactants, low temperature and high pressure. Question number 18. Though N exhibit +5 oxidation state, it does not form pentahalide. Again, answer is it is due to the absence of d orbital. Question number 19. Give reason for the following. White phosphorus is more reactive than red phosphorus. PS3 has lower boiling point than NH3. The +5 oxidation state in BIE is less stable than +3 oxidation state. Answer one by one. Answer of A. White phosphorus is more reactive than red phosphorus due to more angle strain in white phosphorus. PS3 lower boiling point due to hydrogen bonding in NH3 and +5 oxidation state is less stable than +3 due to inert pair effect. Next question 20th. What happens when PCl5 is heated? H3PO3 is heated when phosphorus is heated with concentrated NH solution or in an atmosphere of CO2. Give equation. Equations are given below one by one. PCl5 heat, PCl3Cl2, H3PO3 heated, H3PO4 PS3. When phosphorus, NaOH and H2O, then it will give H3PO3, 3NaH2PO2. Question number 21. What is the basicity of H3PO3? Basicity is 2 because it contains 2 OH group. Actually, oxoacid phosphorus are deleted from the syllabus. Now, their structure is still there. Hanji, give reasons. P has more tendency for catenation than N. H3PO2 is a stronger reducing agent than H3PO3. The answer is A portion. Question is P has more tendency for catenation than N, and answer is because PP bond is stronger than NN bond due to less repulsion between bond pairs. H question number B, H3PO2 is a stronger reducing agent than H3PO3. Answer is H3PO2 has two hydrogen directly attached to phosphorus. Now, question number 23. Why does R3PO exist but R3NO does not? Answer is same. Compound like R3NO does not exist because here nitrogen is forming 5 bonds. 2 with oxygen and 3 with R. Does not exist because the absence of d orbital. Again, answer is in valence shell of nitrogen atom. As a result of this, nitrogen can't expand its covalency beyond 4. On contrary, R3PO exists because phosphorus has vacant d orbital in its valence shell and can expand its covalency beyond 4 by forming d pi p pi bonds. Hanji, how does ammonia react with a solution of Cu2 positive? Equation is given. Cu2 positive plus 4NH3 changing into CuNH3 4 time and 4 charge on whole is 2 positive. Question number 25. Can PCl3 act as oxidizing agent as well as reducing agent? Justify. And as a reducing agent, equation is given here. PCl3 SO3, POCl3 SO3, SO2 sorry. It is their reaction as reducing agent. Now as an oxidizing agent, 12 Ag plus 4 PCl3, 12 AgCl plus P4, it shows its oxidizing behavior. It is due to the fact it has oxidation state of plus 3. Therefore, it can not only accept 2 electron and change into plus 1 state, but also loses 2 electron and changes into plus 5 oxidation state. Next question is arrange the following in the order of property mentioned against for each set. PS3, ASS3, SBS3, BIS3 increasing boiling point, NS3, PS3, AS3, SBS3, BIS3 increasing basic nature. Answer is given below. Order is given here. Question number 27. H3PO2, H3PO3 are reducing while H3PO4 not due to absence of pH bond in case of H3PO4. Question number 28. What happens when white phosphorus is heated with concentrated NaOH solution in an inert atmosphere of CO2? This allotropy has been removed from the syllabus now. It dissolved in boiling NaOH solution in an inert atmosphere giving PS3, P4, 3NaOH, 3H2O, PS3, 3NaH2PO2. Question number 29. Write the reaction of thermal decomposition of sodium azide. Thermal decomposition of sodium azides gives the N2 gas. Question number next. What happens when PCl5 is heated? PCl5 is heated, then it will give PCl3 and Cl2. Thank you and have a nice day for attending the chemistry lecture. Again, thanks all of you for attending chemistry class.